like to talk with you about security research. And first of all, as somebody noticed, we'll start with preparations for the practical part. You have access to my GitHub repository. I'll show you the link on agenda if not when we start presentation. But just for those that might have started the process of creating a virtual environment, there is a small typo, as you can see, and I clicked and I opened editing. So instead of bveb should be bveb. Just if you were looking for the mistake here. Otherwise, it should work. You just have to install Bandit module and you should be ready to go. Also, for your convenience, exercises that we are gonna do are in folder exercises. Solutions, if you need those, are in solutions, and also there is a nice quick Bandit cheat sheet that you might want to use for all the exercises. And apart from that, there is also a PDF to access the slides. So that would be all in terms of preparations. Let me quickly maybe get back to README. There is also one thing that you might want to download earlier. At the last part, there are case studies. You actually have to download source code from GitHub for 2 vulnerable versions of libraries that you will analyze in later part of the tutorial. So you might want to just open the link, and then there is release version on GitHub that you download as zip, and yeah. So that would be all. Okay. So let me just quickly start the presentation. And I'll take a few minutes, up to 30, I think, to just quickly introduce you to security research in general. I might have, yeah. Should be a bit further from open. Yeah. So I'll take around 30 minutes to introduce you to security research. We'll cover some basic methodologies, techniques, and tools, and then we do some exercises, and then we look into case studies. So a few words about me. I'm Przemek, and I work at Tieto as a network security engineer. And here's the link I promised, if you haven't found it yet. As I said, now we'll cover the introduction part, and later we'll go into exercises. So, what's security research in general? It is a branch of computer science, field of computer science, so to speak, that works with digital threats, tries to understand them, and also learn about vulnerabilities and how to improve system defenses. And yeah, but why would you care at all about security? I mean, this is from just a few weeks ago. There is a recent vulnerability in setup tools, which it has quite low impact because you already would need to have access to victim's computer, but in general, because there is no filtering in some functionality related to downloading files from repository, you are able to write to arbitrary files on file system. So this is just one example, and as we all know, there is a list of discovered vulnerabilities, for instance, on GitHub that you can access using the link. And you would see here that in Python packages, there are about 4,000 vulnerabilities discovered just in this repository. And just in last week, there have been 4 vulnerabilities with high impact. So it is very important subject for me personally, because if it wasn't for security engineers and security researchers that strive to find vulnerabilities and understand them and find them in other systems, then then there would be a lot more computer attacks and all that. So this is, I think, very, very important to do. Okay, so now that we covered why, let's cover how would you would actually work on security research. So I like to divide my work into like maybe three different approaches. So that would be reading research, and then you would learn about your targets, and then finally you would want to upskill or do some exercises that give you practical skills so that you are able to find vulnerabilities. So as I said, building knowledge, and apart from just reading, you might want to take some existing research that's developed that's created by other researchers, and then you would take that research and maybe just try it on your own. Maybe install the vulnerable environment, and maybe try some different angles, some different perspective. This is actually what a lot of security researchers find very useful, because sometimes you just don't know where to start, whereas having research developed by some other security engineers, you at least have some idea what could you start with, and maybe see what other researchers might have missed. And also, when you actually start researching some subject, it might be part of your work, it might be something that you do after work hours. So you would want to actually use the software, maybe read the documentation. There are quite a few YouTube tutorials made by developers where they explain how to understand large code bases. So you might as well just learn from it, because this is like a common goal for you and people that actually try to implement some functionality. You have to understand how a complex system works in order to to be able to break something in it. And finally, I think this is also a very important part, identifying patterns by doing exercises online on platform, different security-related platforms like Hack the Box or so. And by that, you're actually learning to recognize vulnerabilities in different scenarios and different applications, which will also help you in general to increase the quality of your research. So now we'll do some simple exercise, some simple example of how you would identify threats in an application. How would you start researching an application? So we have some simple online shopping platform, let's say. We have functionalities to list products and all that. And you would basically start with using the application and identifying different ways you can interact with it. Maybe you can search for a specific product. Maybe you can access your orders or make an order or else. And once you understand different aspects of application, then you are ready to create some ideas about what could you misuse in the application to steal others' users' data, or maybe make application work in an unintended way. And that's how we built actually a threat model. And this is like just a set of ideas of attacks that you could perform related to specific functionalities. For instance, if you would like to list products, then maybe you could modify those products, or maybe you could change price of those products, and so on and so forth. And once you actually got those ideas, as your working mind map or something, then you start to create scenarios that you start to maybe realize and create different attack. Let's say. You start just to perform different attacks and see out the results, and you always have a baseline behavior. So you see that certain functionality should, for instance, provide you a list of products, and then based on your threat model, you have some idea on how you might break it. So in that way, you have created a list of attacks, and you just go through them in order to identify a potential misuse of the application. Right. So I'd like to split security research into two different perspectives that you could use. And one would be black box testing, where you basically treat your targets as some opaque system that you don't know the structure of, and you are basically interested in interacting with the application rather than understanding how it works under the hood. And there is also white box, where you have clear structure and you are interested more in the functionality. And also, finally, there are different gray box approaches, where you might have some understanding on some parts of the system, but not all. So yes, example of white box would be, you have access to the source code and you are focused on functionality. Whereas on the black box side, you just have some opaque system that you provide some information, you get some information back. And then you try to understand whether you were able to successfully perform the attack or not. Think like maybe you have a microwave without any buttons, and you just put some stuff inside, and then you see what comes when you open the microwave. Don't try it at home. But yeah, that would be the general idea. And from those two approaches, we have two kinds of tools that we would use. And first is dynamic application security testing tools. And those try to benchmark applications behavior by sending different inputs, often unexpected, and then analyzing how the application reacts to them. And on the other side, I might have clicked one time too much, maybe. Oh, okay, cool. It worked. So on the other side of the research, you can do code review. As part of static analysis, and you could also try to search for vulnerable signatures, and that would be for instance, some methods, some function names. And finally, there is one approach that's gotten very popular over last few years. You could analyze abstract syntax trees in order to maybe understand the code structure a little better and relationships between different entities in code. And you would say abstract syntax what? And this is my actually next slide in order to so I could introduce to the concept if you haven't heard it before. Right. Abstract syntax trees is basically a data structure that you use in order to visualize relationships between different code entities, and it is commonly used in compilers, but also security researchers take advantage of it in order to understand the code structure better. And something's with screen again. And the example of such tree, it is kind of a strange tree because it has a root at the top and leaves at the bottom. But you can work your way through it. Sorry. So you would basically start with file, and then you have some functions, maybe some expressions, and then go through the whole structure of the code. landing at most simple objects in your program. And there's a simple way to parse your program in order to get abstract syntax trees, and that would be by running the example that is also in the repository. And I provided an example of how it would, how the result of such script would look like. So here we have some example program, just a hello world script that prints something out to the screen, and then when you run the code that was on previous slide against this script, and you would just need to provide name of the script as a parameter in command line, then you would sort of get the structure of the script. And it would always start with a module. And then, for instance, since on the line 1 there are some imports, and those imports are objects that will be returned by AST module that you can go through and see what attributes they have. So this particular object will have parameter called or parameter of value sys for parameter module. And then there will be like also other objects, for instance, expressions for calling the function on line number 7. There will be also function definition, and function definition has somebody, and the one element of the body array that you can go through is assign statement on line 4. And this assign statement would also have some objects related to it inside its parameter, so that it's just one big tree of different relations between objects in the code. And it's kind of like there's all the objects like they have just a one parent which is module, and all of them are like on the same level, and from that you go deep down and see what other entities are below. So now there would be first exercise for you, which is to run AST module against some other program, which basically prints some strings from Python Zen. And yeah, I'll give you a few minutes for it, because there are also a few other exercises after it around parsing AST. And if you have any questions, let me know. I'm here for you. And yeah, I'll give you a few minutes.
First question.
Sorry.
So what is CTX?
Come again?
CTX. Because I can see CTX load, CTX4 is just an operation.
That would go for context, and actually, maybe I show it for on screen so that others might see as well. Oh yes. That would be a bit difficult for me to type, and but we'll see. Okay, so if start your get AST. So I'll walk quickly through the exercise in order to maybe explain it better on the question. And then we do exercises and AX1. Yes. And we've got a pretty print of the script that we're analyzing, and there is a sign. Hold on. Just let me make the font maybe a little bit bigger. And there's like this parameter called CTX, which I think stands for context. I'm not sure right now, but you have to access AST's documentation in order to learn about all the different parameters that are here. But in general, it tells you the target operation maybe of this. There's like inside this target, that the first target is name. So I would only say that there are, it kind of tells you what operation is done on this particular variable. Like there could be store where you store some information inside its name. You could load some information from it, and I think you could also there was third context value that you could that could appear, because there are like limited to a few a few possible values that this parameter can have, which is kind of cool because when you start to learn about abstract syntax trees, and particularly for Python, and you access documentation of AST module, then you could actually learn what different operations on different objects you are able to perform. And you sort of start to treat code as large database with relationships between different objects. Yeah, sure. Any other questions, maybe, or is it clear? Maybe. Okay, cool. Any other questions? All right. Okay, so as for exercises, we are doing now this part, and the first question is, what is the name of AST node type online? And this is gonna open editing every time I click on something, so I need to not click, but yeah. What is AST node type on line 3? So we do have output of the AST parsing, and we search for. Oh yes, and now I see that this would actually I changed module for presenting AST nodes in the middle, and this is my mistake because I haven't properly tested it. But if you do, am I in Venv? Yeah, I'm in. So if you do install AST. Was it like AST pretty print, maybe? Print. Maybe, not sure. No. The thing is that if you get to the code, I'll show you maybe.
AST pretty?
AST pretty, maybe, yeah. Okay, so let me show the code first. So I used dump from AST instead, which doesn't show all attributes of those nodes that it analyzes. If you would use as you said, maybe we'll add this to the code from AST_pretty, was it? Pretty import pretty print, and then you would use a pretty print here. Of course, I would need to now install it. Pretty. I think that would be the fastest way here. And then you sort of run this exercise again. So yeah, apologies for this not testing this thoroughly, but now we have access to other parameters as well. And you could also just run the script and maybe add -i parameter at the end. Maybe it should be before positional parameters, not positional. Yeah, but yeah, it works. Then if you specify -i at the beginning, then after the script was run, you could actually access the Python interactive console and sort of experiment with it. So there is 3 objects that we can access. And then, for instance, this might not be visible because it's so low, but and sorry, just let me make the font a little bit bigger. So now you would do dir of tree, and then you have all different attributes that this object has. And you would be interested in fields, screen again, and you would be interested in looking at array of fields. Apologies for the screen blinking, but not sure what's the cause of this. Fields, sure. Okay, and then you see that the only field that you have is body. So then you do access its body. Or maybe, sorry, it should be like this. Apologies. And I'm blank right now. Hold on. Come again? Yeah, you can't access name element of array with. Okay, sorry. This is just a list of strings, and then you would need to. There's actually parameter body somewhere else. And apologies, yeah. And then you get array of all the objects that are in the module, and then you sort of can recursively iterate over those objects and check their attributes and so on and so forth. So this is just for experimenting with AST trees. I hope you'll find this useful, but otherwise, as far as exercise 3 goes, what's type on node type of AST node on line 3? If we get back to the output of pretty print that provides more information, then there is assign line number 3. And then this would be, I guess, assign, I think, because this is number 3, or whatever else the author had in mind. Yeah, it is assign. So this is, just a quick exercise in order to make sure that you know how to get attributes or objects from the AST output. Cool. I really recommend you to spend some time and understand more of AST trees because this would basically allow you to understand better how Python works in general, or maybe will help you to improve your researching skills a little bit, as far as understanding code structure goes. And am I able to? Yeah. So I think there is like we're past the theoretical part. So now we'll just do a quick introduction to Bandit tool, and this is in general a open source linter that checks Python syntax. It basically analyzes AST of the application that you want to analyze and runs a set of plugins against it. And from now on, the slides might be a bit verbose because I try to provide different use cases and stuff that you could do with Bandit. But I won't cover everything here on the presentation. This is rather for you to have like supporting material in order to to experiment in your own time. So this is installation, and there are some basic actions that you could do with Bandit. And as for implementation, it uses, as I said, it parses AST, and it implements node visitor paradigm in order to visit all the nodes. But what it does basically is it provides you API that you can use in Python directly, which you can use to interact with AST nodes without having to dive too deep into the structure. So you have just some methods that you can use to quickly assess some properties of the code. Yeah. This would be example of output if you run some of the standard plugins or non-standard against some vulnerable application that uses MD5 functionality. And plugins provide you more information about specific vulnerability that was detected. And one example of that of such vulnerability that you can find with Bandit in your application would be SQL injection. And just a few words about what SQL injection is in general. So you have a database that uses SQL, and you can interact with it by, for instance, getting information about some specific product in the database, and you would get the information back. So that simply works. But what if you provide some unexpected input to the functionality that interacts with database? For instance, you provide some special characters. And in that case, you can force the database to do some other functionality that it was intended to do. So, for instance, that would be like the worst case. In this example, you would be able to access information about other users, about users in general in the application, even though in the first place you were supposed to access only information about products. And this would be an example of such vulnerable implementation. And as you can see, there is a string built from user input from the parameter that is provided by user. As a form of get parameter in get request, and it's joined with sort of query that gets sent to the database and returns result. And this would be a one situation that we are interested to find in our code base to make sure that that we will be able to find this functionality before we actually ship the code and before users are able to access it. So a few words about how you would detect such such vulnerability. And in a few steps, this would be like parsing AST and then finding instances of string concatenation in general. So you are interested in any strings in the application that are being joined together, because this is like first indicator that you might have. This would be first indicator of this vulnerability, but it is not enough. We also need to compare those string concatenation instances against regular expressions that only, that would filter out only results related to to interaction with database. So this particular situation. And finally, when we do have a string concatenation which matches our regular expression, we would want to check out whether this query is actually used in database. And then it would constitute a vulnerability if there isn't like any filtering in between. But we'll talk about filtering a bit later. So this would be finding different instances. This would be like part of a Python plugin that finds different instances of string concatenation. And then you would sort of analyze those different instances in order to connect joined strings, because since there are like there might be variables inside connected strings, you need to build complete string, and you would do this with concat string function from Bandit that will return you complete string, and we also return you wrapper functionality, so that you are able to test whether it's actually used. So later you will compare this complete string against regular expressions, and finally you check if this wrapper method that you got in the first point was actually one of the functionalities that are used to interact with database. So in that case, we would be like joining all this functionality. We would be able to create a complete plugin that finds SQL vulnerability. And example of such plugin would start with some decorators that are basically, defining some special attributes for Bandit. And the first attribute, test that checks, defines what particular AST node you are interested in analyzing. This would come clear in a second. And after that, you also define sort of a test identifier, so that you can call specific plugin by its identifier. And then you have you define the main function of the plugin, which takes one parameter, which is context, and we'll talk about this in a second. And then you get information from all the nodes that you process. And this would be, in our case, only string nodes, because we are only interested in string objects for our application that we analyze. And when we find the specific string concatenation that matches our other conditions that we talked about, then we basically return issue to the user of Bandit, and and inform the user that there's been a vulnerability detected in the script. And that would be one example, but I would like you to now work on your own scripts for other vulnerabilities that we have in this workshop. And before we do, I want to quickly just introduce you to the structure of Bandit plugins. And as I said, the first parameter is the only parameter that such plugin would take is context, and this is defined by Bandit in order to, it provides you basically API to interact with different aspects of AST objects. and even would be able to, for instance, get parent node of some AST node that we analyze. And there are also some helper tools and checks. And on the right, you can see like the most basic plugin that you can start to work on. And this would be also, I cannot switch to GitHub right now. Let me finish the presentation, but this would be also in, I think, first example or on the cheat sheet. It should be at the top of cheat sheet. So you can, copy the code and start working on it. So yeah, context provides you different ways to interact with AST, and the problem is that Bandit is quite an old tool. It was developed a few years ago, and since then it was abandoned, and then it was picked up by some other team that now works on it. And it is active. It is only occasionally maintained, but it has some issues that I hope will be quickly addressed, because I think it is a great tool. And one of those issues is that actually you cannot add your own plugins just by as a functionality of Bandit. You would need to compile your own Python module, and just install it as any local Python module, and then you use sort of special attributes in the setup of your module, so that Bandit knows that this module is installed and it can use it. And if you would quickly see, I point with my hand at the entry points, this would point Bandit to the specific module that you want to attach. And the naming convention here is that there is name of the subfolder. If you take a look at the left side of the screen, where there is like complete directory structure of such plugin. And after the name of subfolder, there will be name of the script that implements your plugin, and then name of the main function that takes context as a parameter. We'll see. I show you quickly example in a second. And yeah, so this is how you would create your own plugin, and now you have a few basic steps in order to be able to install it and then run it. And finally, also if you'd like to modify the package, the plugin, you don't have to reinstall it all over again. Instead, you could just, it's a bad hack, but you could edit the module implementation directly in installation of your Python. This would be okay for just virtual environment and experimenting, but obviously there would need be they need to create a way to install plugins some more efficient way. Okay, cool. So now for exercises, we still have a few minutes left, so this will be time for you to actually experiment a bit with plugin. So I would suggest to take a look at Bandit cheat sheet file that I provided. And from there, you would take some simple script. I have even, I clicked again, sorry. I have even provided you example AST node name that you can use, and plugin identifier, but you can change this to whatever you like. And before I let you do the work and solve exercises, that would be if we go back to README. I'd like you to take a look at analyzing function calls. So I'll give you a few minutes to read the questions and then try to experiment on your own. But just a word of warning. So I jump into my console again because Bandit will not let you know that easily that something is wrong, for instance, with syntax in your plugin. So I could actually maybe open some other file, some new file, and let's call it testp.py. This should be actually, I would need to create entire plugin here, but okay, the point is, so maybe I will create the plugin, then I will show you, but otherwise you can do it on your own. But the thing is that the Bandit will not let you know that the plugin wasn't installed properly when you are installing it, because you just install Python module. It will only let you know when you run the plugin against some code that the plugin wasn't run. And now it's on you to fix your plugin, and then maybe find the syntax error that is in the plugin, and yeah. But maybe I show you, but I let you to do on your own do the exercise on your own as well. Yeah. Just forgot to mention, if you have any questions, just let me know. I'm here for you. So I now install the plugin, and after that, I'll show you a few possible issues that you might encounter. First questions, yeah.
Can I use a PyProject terminal instead of setup.py?
Come again?
Can I use a PyProject terminal instead of a setup.py? Which is
I think,
setup.py
yeah.
has been deprecated for quite a while, I would say.
I think you can. I know then, instead of virtual environment, instead of Venv, right?
To create the package using a setup.py to creating a package is something you shouldn't do anymore for any new code. So I moved all my old code from setup.py to PyProject terminal. So that should work because it's just a different way to build a package. And I'm not sure if there's anything specific to Bandit that you need to use setup.py instead of using
No, you might define this next train that PyProject terminal.
It works, yeah?
Yes.
There's nothing specific that works.
This is the default. This is the default way which Python suggests to provide the plugins to enable a platform, and it's of course it's supported in PyProject terminal.
Okay, so there's nothing special in the setup.py that I need to use.
No, this is the suggested way of discovering plugins by the Python, and all tools I use and are using this to discover plugins.
Okay, good, thanks.
Yeah, I haven't experimented with this myself, but as far as I know, you only have to provide the entry point for Bandit so that it knows where your plugin is in setup.py. So if there's equivalent in other package managers, so there might be some other way. Yep.
Because it's still work, and if you know the problem with Tom,
Okay, so how are you doing? Do you have any issues? Are there any questions? Right. I must tell you something. I have made your job a little bit harder just by pure accident because I committed. I show you. It was there. I committed the part of plugin that I was testing instead of just provide true here so that you would be able to test this easier. So let me just show you. But happens to all of us. Just ignore the prints here. That was me debugging stuff. It doesn't matter. And as for the plugin, let me just quickly show you what it should look like. So you obviously have test P. Maybe let's start with setup UI and hold on. No. So let's do this just the old way. It will be faster instead of jumping to Visual Studio code all the time. You would need to make sure that the packages has the right name of your directory, I think, and then you have to have the correct start point for your plugin, and that would be ls test p. Maybe let's do cat this time. Test p my plugin. No, there's a nested directory with the same name, and then there would be a file called my plugin. So this is like the first part here, and then there is a definition of the function which you reference after the column here. So that's how you get like the path to your plugin. And then, as you can see, I removed the print stuff that I told you, and I just added true, so that it will print you issue for every node it will encounter. It could be good for debugging in our case, but you could also employ debugger in VS Code in order to do it more efficiently. But just to start, and now you would want to run the plugin, so you do basically you do bandit, you provide name of the file that you want to test against. Let's do this against exercise 3. I skipped exercise 2. Just by mistake, but I'll get back to it in a minute. But this was basically to run the plugin that we talked on the slides against vulnerable to SQL injection script. That is an example number 2, but we can get back to it, sure. And then you do -t for specifying the test plugin that you want to run. 1, 2, 3, 7, and then you could also do -f for format and specify custom to give you a bit less information. And then you have information from Bandit that it will include the test. So that is the most important information for me when running my own plugin, is that it was successfully loaded by Bandit. It could be more verbose, but if we would do, and now I could access, not sure how is this visible from the end of the room, but you would access side packages of your virtual environment in order to edit this plugin when you installed it. I skipped the installation step, but it was in the repository in the README. So when this is installed, and you can actually start to experiment with stuff, and let's say that you will do some syntax error. For instance, you forget some column. Okay, cool. And then you run it again. And it will say unknown test found in profile, or it may say also it didn't find any test with this profile. So that would be what I just installed module. So what happens? And this is just, you know, Bandit not being able to parse the plugin file, and you have to figure out on yourself. That might change in the future, but still for now it's a little bit troublesome, and this is how it is. Okay, so let me just quickly bring the correct syntax. Okay, cool. And as for the other exercise that you're supposed to run, you could do, if you don't remember which test was for particular vulnerability, you do bandit-help, and then it will just list you all the categories that there are defined plugins for. It even lists our example script that we created with some name. I don't know, maybe it's a leftover from some other plugin, but there's the name of the plugin. And then you would look for SQL, or maybe injection, not sure. Ciphers, hard-coded, no, it's not here, I think it's 6 or something. Hard-coded SQL expressions, that should be the one. 608. So now we would like to run the plugin against our vulnerable exercise file. So that would be P608, and then exercise 2. And you could do again custom for shorter output. And you get output saying that, I make this a little bit higher so you could see, and Bandit returns that this is vulnerable to SQL injection. But back to our own plugin. Do you have any questions so far? Okay, cool. So now the idea, once you have a working example plugin, if I get back to the README, sure, there is, yeah. So common function calls are present in the file, and I clicked for the solutions, but you also have solution in the solutions folder. So if you quickly visit it, hold on, maybe too big. Okay, so what you see here is you basically return information with severity low, because for me it would be like severity information, because you know you just give information to the user that there is a function in the file, there will be several alerts like this. So this is just for you to, you know, kind of simulate or analyze the structure of the code. And it will basically return to you that there is a function and there is no info severity in value. That's why I used low. And you would also provide the function name that was detected. So if we now run this example, So that's how you would access the plugin code that you want to edit without having to install the module over and over again. Might be okay. Function name is different. Okay, and now you get all the functions names, and if you like to count them, you can, word count -l. And there would be 17, but I don't know about all the other lines. Maybe they get counted as well, or maybe it's part of standard error output, not sure. But yeah, that's how you list all the functions in the file. And from now on, this would be like our first idea to when you start researching new applications. You sort of try to get idea on what functionality is inside. So that's how you would list function names, and from now on for our application, for our example script, this is like only a few functions, right? But for a huge code base, this would be thousands or maybe of functions. So then you would need to somehow filter this list of functions to meet your specific criteria that you think it would need to meet. And you could go different ways here. You could either, find vulnerable function names, or maybe you could find specific names of functions that take input from the user, and those would be sources in your analysis. And source is like a term for a function that provides input to your application. And then, going from sources and through different functions that might handle user input, you land into functions that might finally do something with this input. And if this input is not properly filtered, then it would constitute a vulnerability, right? And this would be several different functions that it could be executing a command with input that provided user, but user was supposed to only provide a name for some parameter, but the user input wasn't filtered, So that would be just one example. So let's see at the other exercises, since we are slowly running out of time. So the first idea is to see how many function calls are present in the file. Then you would see how many functions with variable arguments are in the file. And then, adding to previous ideas, you might only want to find imported functions, so that you could further limit your focus to only some small set of functions that might or might not be vulnerable. Then you see what functions meet your criteria, and then you evaluate your search further. So this is basically, like creating a search query that will hopefully return you a vulnerable function that you would be able to report. So that's how this game is played, I think. So we would want to firstly enumerate all arguments in a function, and then if some argument is a of type name, which is for variable types that user could have provided input for, but it may not be the case as well. We'll see why later. But in that case, you would return issue informing that there was a functionality fault. So let's try to run this code again. And then we would get a list of different functions that meet our extended criteria. By the way, I hope you don't mind my choice of IDE, Vim and Terminal. I think you have a better setup, but it was just to quickly show you some ideas. So in that case, because we are still running the tool from the terminal, the tool that we use to quickly edit our code is not that relevant at this moment. But as for our return, what the plugin returns, we have names of different functions like open, print, traversal, replace, and also the arguments that are used in these functions. And from that, again, we only just checked with functions with variable names. Then we will quickly go to another step that we can go through, which is to limit to only those that meet. And this is again some debug code that I left for myself, but yeah, let's quickly add this plugin. So let me just show you maybe how you would approach this, since this code is not really helpful, but there is some function in cheat sheet that we could use here for establishing whether the function that we analyze is imported. So this would be, I think, yeah, anyway, so the thing is here that I jumped to next solution because it will also contain information about that was missing in the previous example. But the thing that the function that we will look that we want to use here is is module imported live, and you would actually need to check if a specific module was imported or not. And after that, you also check a function name, and the check that we did previously for establishing or for finding only functions that have last argument as a variable. So the idea is here that you would basically go through maybe different imports and different libraries, and there is no easy way here because you have to read about all the functions that are used, and either you have an idea on what specific function that you look for, or you basically read about all the functions that are imported and sort of try to get an idea of what this function does when it's imported, and what it does, and how it interacts with the underlying system. So in our case, I'll run the example first. Are there any questions right now? Okay. So let me just quickly fill my example. And maybe I just quickly revisit the example, so I have we have like syntax highlighting, but there's actually a bit more on the reporting side done by Bandit. So there are a few parameters for this issue that we are reporting. This would be severity, confidence, and it's all defined by plugin author. So for instance, when we detected SQL injection, you might have severity of high, because this is high impact vulnerability in this specific example, but there is confidence of type low, because it might as well be just some other string concatenation in some specific instance of detection. And there is also CWE, which is short for common weakness enumeration, and this would be in our case improper input validation, which is a common weakness enumeration is just a set of vulnerability characteristics or vulnerability class of vulnerabilities that you might encounter. We found CVE in the beginning that was identifier, and CWE is represents some class of vulnerability. And there is also there is a question. Yeah.
So I don't understand why you say, so for this specific case, like using the join function name,
yeah.
So we are not so sure that it's actually a vulnerability, because the join function is not necessarily imported from OS.pass first, and secondly, maybe the name that's passed as argument has been sanitized one way or another by the program.
Yes.
Yeah. So I would have expected confidence to be low, and severity to be potentially high, no?
Could be, yeah. I think what you mean is we basically check if the module was imported, but not if it's used by this function, right?
It could be a join function imported from a different module, because...
Yeah. For that, you would actually, it's a good point here, you would actually need to use other function in Bandit. That would be qualified function name, I think, and I clicked again, sorry, but then I think you would get a complete path from the module, submodules to the function name.
Okay.
But otherwise, if you, for example, do...
And
okay.
also for the name
Yeah.
arguments, we don't know if the program is actually doing some checks that it's safe variable, safe input. Maybe it's actually not user provided. name, it's actually computed by the program one way or another, but it's actually safe.
It might be, exactly. The problem here is that Bandit is not capable of taint tracking. It is a term used in static analysis, which, or maybe like a technique used in static analysis, which helps you to trace user input from the source functions, like reading from the file, to the execution functions. And this would be possible in more mature tools like CodeQL, but unfortunately it's not implemented yet in Bandit. So you would need to, I tried this myself, but it's not like, it's not very doable like manually to inspect AST module, because there is no API for this in Bandit, but you would need to find parent of the variable, and then sort of trace the name to where it was provided from. But there is no easy way. But yeah, that's true.
CodeQL is able to do some kind of shallow semantic analysis of the syntax tree to trace the provenance of a variable and see that it's derived from a user provided input and that it's not safe as a result. It has this kind of.
I wouldn't say like you speaking analysis here, and I only can answer that it can provide you information that about the flow of a certain variable being passed from one function to another. So that would be tracking the time steps, right? But not necessarily that it has some database of functions, or maybe it has. I'm not aware of it, because we are more focused on Bandit here. That it would tell you, for instance, that this is for input and this is for executing something dangerous. So you would need to know this yourself. Otherwise, you just would run some CodeQL script and it will find you all vulnerabilities. You have to find the specific functions that you are interested in yourself. And this is the same case here. And okay, yeah, we are out of time already. Thanks. So just a few words for the end. Where we finished is like you would want to now use this module to run against the example that was provided, and then you can, as you mentioned, not with high confidence, but with some confidence, tell that there is like this function from this module being used. But you would also need to refine the script further to have a higher confidence. But this is just an example of what you could use and iterate upon. And finally, I left you. Let me go to README, and I left you two cases, and one of them you could use the plugin that you developed. But there will be some issue which I think you give spoiler alert for, because there is some other. The import is used in a different way, but it is this vulnerability is about using the same function. But you would need to figure out yourself. Otherwise, you can find online the CD that the software is vulnerable for. And finally, if you are hungry for knowledge and you would like to learn more, there is some other exercise that you would need to develop another plugin from scratch, and then find some other vulnerability in InvokeAI application. So that would be all from the exercises. And I mentioned already time tracking about Bandit future plans, but there is also some other plans that they have, like extend plugin coverage, which would help a lot, because for now there are only a few plugins that you can use, compared to, for instance, 350 rules in SameGraph. But again, this will be like plugins that everyone can use. But for hunting and finding vulnerabilities, identifying unknown vulnerabilities in software, you would actually need to create your own plugins. So this is quickly a summary, and I also left some links for you that you could access in order to learn more about security research, static analysis. It should be here, and also some tutorials if you'd like to exercise on some other targets. And yeah, that would be all for me. Apologies for taking 2-3 minutes too much. And yeah, thank you for your time. Yes?
There's a long list of all these things. Is there a way to get documentation that's only just one name? I would like to get a help message, and also if I create my own plugin, what would be the best way to put a nice help message so if you look at it, you can read some more text about what this plugin or this test is doing. So what would be the best way to get information about all this many tests? But actually, this is just one straight and say, okay, and I might not understand what it is.
Yeah, there is no official documentation on how to build your plugins. You would actually need to take a look at how other plugins were implemented, but there is actually a doc string at the top of each plugin that is, for other existing plugins is very well written, and there are examples and references to CWE and so on. So you actually have a lot of information there.
Is there a command line option? Say, okay, please show me the documentation for this test. Would this be?
Might be. I'm not aware of it. I only checked in the source code on the GitHub, and I'm not sure. This might be even in the cheat sheet, but I'm not sure if there's provide me all information about this plugin. But they sure have this, because every plugin has a lot of docstring information at the top on all examples and all that stuff. Yeah. And other questions? Okay. Then, if you want to catch me later, I'll be around here, and we can also get in touch online if you like. There should be some contact links on the repository. But otherwise, again, thank you for your time, and see you around.
Yeah.